All right, problem 3 says that a line segment is 8 inches long. 2 points are put on the segment at random locations. What is the probability that the 3 segments formed by the 2 points will make a triangle? All right, so basically we have a segment that is 8 units long. And so we have 2 random points on there, B and C. So the first one will be X, the second one will be Y. So then that third one is determined. It'll be 8 minus X minus Y. So this time, when we go to create our sample space, the longest X could be would be 8. The longest Y could be would be 8 as well. But because of the limits on the segment, we're not going to have a square. They can't both be 8. So this time, we're going to have a triangle for our sample space. All right, then you guys have to use a little geometry and your triangle inequality theorem. Okay, which says that the sum of the 2 smaller sides needs to be larger than the third side. Now, we don't know which one's going to be the smallest or largest in this case, so we have to set up 3 inequalities. The first one would be, let's say, CD is the biggest, so then X plus Y would need to be greater than 8 minus X minus Y. When you solve that, you have 2Y is greater than 8 minus 2X, so Y is greater than 4 minus X. So if you graph that here, okay, graphing this inequality, it would have the points 0, 4, and 4, 0 on it, and then we would need to be above that line. All right, but then we have to see what other limits we're going to have on here. The second limit is, let's say, X plus 8 minus X minus Y has to be greater than Y. So then solving that, you would end up with 8 is greater than 2Y, or Y is less than 4. So that's a horizontal line here, and you need to be below that line. Then your third restriction would be if Y plus 8 minus X minus Y was greater than X. So you would have 8 is greater than 2X. So So X needs to be less than 4. So that's a vertical line, and we need to be less than, so we're going to the left. So the region is this triangle right here. And so then the probability is going to be the area of the shaded triangle divided by the area of the big triangle. All right, so the side lengths here are 4 and 4, so the area of that shaded triangle is 1/2 of 4 times 4. The side lengths of the big triangle are 8 and 8, so its area is 1/2 8 times 8. When you multiply and reduce, you get a probability of 1/4.